Hello everyone! Today I want to talk about 3D modeling, specifically the process of creating a 3D model and some tricks that can help the result look better while preventing your computer from overheating and exploding. So, what goes into creating a 3D model? First, you have to get software to create one. There are many out there, but I used Blender because it's free and has many tutorials available. Next, you have to actually create a 3D model. But before that, you need to know some basics. First, what a 3D model is made out of? Polygons. A polygon is a triangle that is composed of vertices, aka the corners, edges, the line between two vertices, and a face, the flat plane between the edges. And it's always a triangle, because your GPU can only compute triangles. But why whenever I see a 3D model, it's made out of squares? The answer to that is pretty simple. 3D artists make their models from squares because it's easier to work with them than with triangles. But those squares end up being split into triangles by your computer anyway. Now, how does the 3D model get its color? A texture. A texture is a square that has something painted on it. It can range from a single color to all sorts of intriguing patterns. And it doesn't have to be only paint. As far as the computer concerned, a texture is just data. So it can be an AO map or a normal map, to which we will get later. Anyway, back to what I was talking about. How do you put a flat plane on a 3D model? You make a UV map. Basically, you take all the polygons on a 3D model and cut them in certain places and then flatten them out on a texture. Kinda like stitching clothes, but in reverse. Oh, and when you make a UV map, it's very important that you stretch and squeeze the polygons as little as possible. Otherwise, the texture applied on the 3D model would end up being stretched and squeezed too. Okay, now that you know what a texture is, let's talk about other types of textures, more commonly referred to as maps. For example, a normal map is a map of normals. I know, very complicated. Basically, what it does is tell the lighting how to behave in this or that part of the model by creating small details without making more polygons. Also consumes a tiny amount of computing power compared to adding detail by making more polygons. Usually, normal maps are created by first creating an incredibly detailed high poly model, then baking that model onto a normal map, which will be later put on a lower detailed model. And now we gradually go towards how does lighting in video games work. I'm not going to go into detail because it's such a complex topic, but what we will talk about is how does ray tracing work and how do you get your game to look like it has ray tracing without actually having it. So at first, how does ray tracing work? Basically, you shoot millions of rays of light and look where they hit and how they bounce. The amount of bounces is limited in order to reduce the load on your GPU. There's also path tracing, which doesn't limit the amount of bounces and looks more realistic, but it requires a lot of computing power. Both of these methods require special hardware though, aka the RTX capable GPUs from Nvidia or AMD's 6000 and above series of GPUs. There's also Lumen, which is software level ray tracing, which means that you don't require special hardware, but it looks kinda bad and the lighting changes if you look in different spots and so on and so forth. I'm personally not a huge fan of Lumen in video games, because not only is it kinda heavy, it also doesn't look that great in my opinion. It does make the life of a game dev easier though. And now we get to the king of them all. Baked lighting. Basically, baked lighting is ray traced lighting that has been pre-rendered by the developers, and the data that the devs got is stored directly in the textures. It does come with its own limitations. First is that it's not just a click one button and it works type of solution. The dev has to manually put a lot of things in place in order for it to work. Since the light is baked into the texture, it becomes a part of said texture, and if the object whose shadow was baked into the texture moves, the shadow stays in place. This method also doesn't take any GPU power, aside that which is needed to render the texture, so it doesn't only look good, but it's also very cheap performance-wise. Another part of lighting is ambient occlusion. With ray tracing, you usually get ATAO, aka ray traced ambient occlusion. But if you're not using ray tracing, then you have two ways. You either bake it kinda like baked lighting, except you could theoretically use it on non-static objects to give them a little more depth, or you could use SSAO. What's SSAO, I hear you ask? Well, it's screen space ambient occlusion, which is basically ambient occlusion on the fly, but only where the player looks. It does a bunch of funky math to give your visuals more depth. The only downside is that it's pretty expensive. And the last part of lighting I want to talk about is reflections. As already said, it can be done with ray tracing. Aside from ray tracing, there are three main methods that I'm going to talk about. First method is SSR, or screen space reflection, and what it does is shoot a few thousand rays from the player's camera onto the reflective surface, then bouncing them and looking at where they land, then replicating up after the texture that they landed on onto the reflective surface. It's kind of expensive, but it's cheap enough that you can use it relatively often, but it starts to break if you look at it wrong, so it's not perfect. Second method is planar reflection. Basically, if you stick an invisible camera into a wall and then tell it to output whatever it sees onto a polygon with some minor adjustments like where the camera should look and what should actually render and with what quality, you get a planar reflection. This method is expensive because you practically render the game twice, so it's only used in specific places like mirrors. Then the third method is, you guessed it, pre-rendering the reflections, which is called a cube map. The restrictions are the same as with baked lighting and AO maps, except that reflections change depending on the angle from which you look at them from. So there is a technology to fix that. It's called parallax corrected cube map, and it's the same old cube map, but it moves around depending on the angle you look at it from. And that's only a small part of all tricks that game devs use to make your game look good while saving that oh so precious performance. Thanks for watching and goodbye!